In this tutorial, we are going to review what we've done in lesson 1 to 9. We started with dividing a polynomial by another polynomial. We started with an example to show the method. 2x4 divided by x is 2x3. 2x3 times x plus 1 is 2x4 plus 2x3. We subtract these two expressions. We have minus 2x3 plus x2 plus 1. Divide the dominant term in the new expression, which is minus 2x3, with the dominant term of the divisor, which is x. We get minus 2x to the power of 2. 2x3 divided by x is 2x2. We multiply 2x2 by the divisor. By doing this, we have minus 2x3 minus 2x2. We subtract again. We have 3x2 plus 1. 3x2 divided by x is 3x. 3x2 plus 3x if we multiply 3x by the divisor. Subtract again, minus 3x plus 1. Minus 3x divided by x is minus 3. Minus 3x minus 3. Subtract. Remainder is 4. 2x4 plus x2 plus 1 can be written as x plus 1 times 2x3 minus 2x2 plus 3x minus 3 plus 4. If we divide a by b, and q and r are quotient and the remainder respectively, a can be written as bq plus r. The degree of r is always smaller than the degree of q. We talked about the remainder theorem. To find the remainder, we set x plus 1 to 0. You find the x value, which is negative 1. We plug it into the dividend. We get 2 plus 1 plus 1, which is 4. The remainder theorem says if we divide p at x by x minus a, the remainder would be p at a. If p at a equals 0, then x minus a is a factor of p at x. Then we talk about rational zero theorem. The zeros of 4x3 plus 5x2 minus x minus 1, the rational zeros of this is one of these, plus minus 1, plus minus 1 over 2, plus minus 1 over 4, if it has a rational zero. In other words, the possibilities for the rational zeros are plus minus 1 over 2, and plus minus 1 over 4. That doesn't mean these are the zeros. We have to check and find. In order to find them, you have to check one by one and see which one makes it 0. Then we used rational zero theorem to factor a polynomial. To factor a polynomial, we start with rational zeros. We plug them in. If one of them is making that expression p at x or dividend 0, then x minus that number is the linear factor. We use division and reduce the degree to factor the polynomial. For example, let's factor x5 minus 32. I don't want to use the identity that we had in lesson 9. I want to use factor theorem. 2 makes this 0. Therefore, x minus 2 is a linear factor of x5 minus 32. Now I divide x5 minus 32 by x minus 2. x5, x4, x3, x2, x, and the constant. This is x5 minus 32. 2 is the root of the divisor. 2 times 1 is 2 plus 0 is 2. 4, 8, 16, and 0. The remainder is 0. The quotient would be x to the power of 4 plus 2x3 plus 4x2 plus 8x plus 16. With the identity that we had an minus bn, when n is 5, we can do it in another way. A5 minus B5 is A minus B times A4 plus A3B plus A2B2 plus AB3 plus B4. And one of our lessons was we were talking about how to solve an inequality. To solve an inequality, we have to start with the equation first. Let's assume we want to solve absolute value of x minus 1, 5x minus 1, smaller than 4. We make this equal to 4. Then 5x minus 1 could be 4 or negative 4. X could be 1 or negative 3 over 5. Then we draw the chart. Absolute value of 5x minus 1 minus 4. Negative infinity, negative 3 over 5, 1, and positive infinity. We plug in a number less than negative 3 over 5 into our expression. Absolute value of 5x minus 1 minus 4, let's say minus 7. If you plug in minus 7, we have minus 34 minus 4, which is absolute value of minus 34 is 34 minus 4, 30, positive. Between 3 over 5 and 1, we plug in negative 3 over 5 and 1, we plug in 0, we get negative, and after 1 we have positive. Therefore, looking for negative, we want to solve this inequality minus 4 less than 0. Therefore, x should be between negative 3 over 5 and 1. Thank you.